Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Carbocation stability is governed by electron delocalization, hyperconjugation, inductive effects, and special structural features. Cyclopropyl rings adjacent to a carbocation provide exceptional stabilization through bent bond, banana bond, overlap. The Walsh orbitals of cyclopropane have significant p character that overlaps with the empty p orbital of the adjacent carbocation. This is known as cyclopropyl carbonyl stabilization. Step 1. Analyze option A. The diphenylmethyl benzhydryl cation C6H5CH plus C6H5 is stabilized by resonance delocalization into two phenyl rings. This is a secondary benzylic carbocation with extensive resonance, quite stable. Step 2. Analyze option B. The structure shown appears to be a cycloheptadinyl cation, non-aromatic 7-membered ring carbocation. This is not the aromatic tropylium cation, which has 3 double bonds and 6 pi electrons. With only 2 double bonds shown and a formal negative sign at the bottom carbon, this appears to be an anti-aromatic or non-aromatic species, making it relatively unstable. Step 3. Analyze option C. The tert-butyl cation, CH3, 3C+, is a tertiary carbocation stabilized by hyperconjugation and inductive donation from 3 methyl groups. This is moderately stable but lacks the extended delocalization of benzylic or cyclopropyl carbonyl systems. Step 4. Analyze option D. The tricyclopropyl carbocation has 3 cyclopropyl groups attached to the central carbocation. Each cyclopropyl group donates electron density through cyclopropyl carbonyl stabilization via overlap of the bent bonds, Walsh orbitals, with the empty p orbital. 3 such groups provide threefold cyclopropyl carbonyl stabilization. Studies and experimental evidence show that the tricyclopropyl carbocation is extraordinarily stable, more stable even than the triphenyl carbocation in many assessments, because each cyclopropyl ring donates more effectively per group than a phenyl ring due to the high p character of cyclopropane C to C bonds. Step 5. Comparison. Tricyclopropyl carbocation D. Diphenylmethyl cation A. Tert-butyl cation C. Cycloheptadinyl cation B. The tricyclopropyl carbocation benefits from 3 strong cyclopropyl carbonyl stabilizations simultaneously, making it the most stable among the given options. Therefore, the correct answer is D. Therefore, the correct answer is option D.